Before Shopify, were you wondering, where are my sales at? But now you're selling with Shopify. You're easily selling online, in person, and beyond. Discover how millions of entrepreneurs use Shopify to ignite their selling. Sign up for a $1 per month trial period at shopify.com/YouTube audio.
If you're texting a girl you really like, but she's leaving you on red, waiting hours to reply, or ghost
Well, it's time to find a new apartment on Zillow. Huh. These are all...
Good evening, everyone. Time to get this class started. Thanks for everyone that's able to join us live. For those that were unable, I know not everyone can make it live, so for those of you that like to watch the recordings, that is perfectly fine. The live viewing just lets you have the opportunity to ask questions. That way I can answer them on the spot and tailor any of the discussion towards anything in particular that you might be wondering. If nobody asks any questions, I'm just going to go over the script. Today looks like might only be about a 30-minute video. We'll try and keep it a little bit shorter. Last week was like an hour and 17 minutes, so I definitely don't want to go that long again. And I definitely do want to try and keep them under an hour for sure. Okay, for week 4, we're starting to get into conditional statements. The if, elif, and else. So for those that have looked at the assignments, this week we have the, let's see, what is it? The conditional module 3, the activity modify, and the activity debug. They are due this Friday, so make sure you get those in before 11:55 on Friday night. If you have any questions about them, you can always reach out and get me on Discord or send me an email. Sorry about To help us get going, we're going to look a little bit at cleaning strings. I know Herv last week had some questions about doing string cleaning. Then we're going to look at some comparison operators. That'll help prep us up for looking at the conditional statements. Then we're going to look at the logical operators, and I was going to do slicing strings, but I think I'm actually going to hold slicing strings off until next week or the week after, because using loops is really beneficial for doing strings. So without further ado, let's go ahead and look at cleaning strings. So this is a continuation. So what is our 4th week of looking at strings, essentially, because strings are a core part of the human language, and we need to know how to process them in any programming language, because there's just so much knowledge and information that's found in books, found on websites, found inside documents, emails, things like that. And you got to know how to process strings. So before we looked at, formatting strings, providing output for people, changing colors, changing the format of strings, how to do inline formats or do the string format. This week, cleaning strings is going to be really small. We're going to be looking at the string.strip, string.replace, and using regular expression. And all these are focused on finding characters within a string and replacing them with something else, or removing white space. Okay, so the first one we'll look at is the string.strip. So wherever you see str, that could be any string. That could be, in quotes, the words hello there, like you can see here in this example right here. And the strip lets you remove all of the white space at the beginning of the string and at the end of the string. So if we hit play here, actually let me go ahead. Oh, sorry, got to connect back to the Google Colab. Connecting, and we are connected. Let me go ahead and clear all the outputs. Okay, so in this first one here, we have hello string, but it's preceded by 2 tabs and has 2 new lines, character, escape characters at the beginning and at the end. If we just go ahead and print it out, you'll see the first one. Look, you have 1 tab here, 2 tabs, and you get the hello, and then you have 2 blank lines. If we do strip, it strips off any white space, any escape characters that add extra space, tabs, new lines, things like that, and it strips it all off, leaving us just with the core itself. And this is nice. This kind of also leads into the stripping. So if you break a string up into multiple parts, you have those blank lines in there. Like if we were to break the word hello and there into 2 different strings, one of them would end up with this blank space right here. So what we could do is we could use strip to then remove any blank spaces that are between words and only have the words themselves as a string. So remember, strip is only for taking out the white space at the beginning and the end. It does not take white space out of the center of the strings. So that's where we look at string.replace. So basically string.replace, we're going to take an old input and we're going to place it with a new input. So it could be a new, it could be looking at taking a dash and replacing it with a space. It could be taking a space and taking it out completely. So with string.replace, it takes the function. It's a little bit better than strip because it does it from the entire string. In this case here, we can use it to remove characters from anywhere within the string. Example we're going to look at here, if we want to take out the dash and a phone number or maybe a social security number, we want to remove just the new lines instead of all white space. We want to move just like new lines only. We can do that with this .strip. So here we have a string, hello, world, welcome. And you can see in the middle here, they have the new line escape characters. Well, if we run it, you can see it prints out on 3 different lines, hello world. And then we can do the print, and if we use REPR, that's the representation. And then we put what we want to see the representation of. In this case, we're going to look at my string. So what it sees is essentially what we have inside our declaration of the string. But let's say we created a string a long time ago, or the string was created through an import or loading a file from somewhere. We want to know what is inside that string. We could use the representation function, and it'll tell us exactly what is inside there. So when you upload a file or you read a file from an external source, there might be carriage returns at the end of every single line. But we don't know unless we can actually see it. So with this, we can actually see hello, world, welcome with the carriage returns inside. Okay, using the replace function, we can say, okay, string.replace, we're taking out the old, which in this case will be the /n, and we're going to replace it with a blank space as the new input. Print, and you can see it takes in hello, world, welcome, all in one single line because we took out all those new returns. And then we can also do the string representation. You can see the actual string itself no longer has it. Now in this case, we didn't replace any blank spaces, and we took all the new lines, so that last new line right here was replaced by a blank space. Let's say you wanted to use it to replace more than just a single character. Well, you could do it like in a phone number. Let's say you just wanted to do a 1, 2, 3, 4, 5, 6, 7, 8, 9 as a phone number with dashes instead. And we don't want it to have the parenthesis symbols instead. So what we do is we can have, let's say we imported from a data sample or from a string, or somebody went ahead and hand typed that in. We can use a string.replace to remove just the parentheses. So using phone.replace, we can make a cleaned phone number. And what we're going to do is we're going to take the old phone number, use the replace, and you can actually do the dot replace multiple times to each other. So in the first one, the first dot replace, we're going to take the old, which this is the old string. We're going to take the left parenthesis, and then we're going to replace it with nothing. So a quote, quote, with nothing in between is basically just remove it completely. Have nothing to replace it with. We'll go ahead and do dot replace again. And this time we're going to take the right quote, our parentheses, and we're going to replace it with a dash. And then anywhere there's a blank space, we just wanted to remove that blank space. So the clean phone number should no longer have parentheses. This blank space here should be gone, and this right parenthesis should actually be replaced with a dash. So when we play it, our phone number is now 123-456-7890. And if you're doing like a Social Security, some people might type in, the first 3 digits and then a space. They might do like a 123 space 45 space 7890. That's for like a social. You could use the string.replace to replace those blank spaces in an input field with dashes instead. And we just looked at phone numbers for removing and formatting how we want to look at it. So the third option that you have is using regular expressions, or often called RE in code. Or you might also see regex as well as another way that it's often displayed. Reg for regular, X for EX, regex. But often called RE when we import. It's actually the RE module, the regular expression module for imports. Another example that we had for the import was we looked at the math module 2 weeks ago, and that was something we imported in to get additional features to the Python language. So this is the third option we're going to look at, and the last option that we're going to look at for this week here for cleaning strings and removing various items. This is a more compact method and is actually more efficient than the string.replace, and is more of an industry standard or professional use for cleaning strings. So we're just going to look at it, just one example here, because it can be kind of complex. I mean, you could have an entire lecture on just regular expressions. So we're just going to look at it briefly here on maybe something that you want to do. So you're going to import the regular expression module. You're going to have a phone number just like we did before. In this case, the phone number is inputted as a string because all inputs come in as strings. And then we want to remove all the parentheses, dashes, and any blank spaces. So in this case here, the clean phone number is going to be, we're taking the regular expression, we're doing a substring. You have to have the R inside the parentheses, and then you have your parentheses. So we're going to move inside these brackets. It's basically going to take anything that's inside there. So it's going to take the dash, parenthesis, and the blank space are all inside those square brackets. And it's going to replace it with nothing, and that'll be the phone number. So the clean phone number would look something like 1, 2, 3, 4, 5, 6, 7, 8, 9. If you didn't want to remove blank spaces, then that's an option that you could leave that in there also. And then you'd have 1, 2, 3 space 4, 5, 6, and then you would have 7, 8, 9 all compacted together on the last 7 digits. So regex is an easy, compact way to remove a bunch of different characters and replace them with optional characters. Now, registry expressions can get super advanced on, let's say you want to remove all capital letters or all lowercase letters. There's shortcut codes like what we did before when we did the %s for strings, %f for floats. When we're doing the dot formatting, you can also do something similar inside the registry expressions. So maybe next week we'll dig a little bit deeper into the regular expressions on how to, I guess, clean our strings a little bit more. Seems like we just can't get away from strings. But without further ado, we're going to look at the conditionals, or build our way up to the conditionals, so it'll help you with this week's assignments. And if anybody has any questions, I'm watching the chat a little bit better today. It's over on my left screen, so I keep looking over to the left because I'm checking for the chat over here. If anybody has any questions, speak up, and I'll try and find an answer for you. On the spot, math in public's always fun, so we can always try a little snippet of code if we have to. Or I can take that as something to add on to next week's topics, because we got 2 weeks of looking at these conditional statements. The first 2 weeks, or this week, is the module modify and the debug, and the next week will be the actual conditional program. Okay, so the first part of, let's see, comparison operators. So the first part of conditionals is you have to be able to compare one value to another value and come up with a true or false. So what they do is allows us to compare values, which is kind of the core of how programming works, because computers work on a 0 or 1 or a true or false basis. Either it is or it isn't. And depending upon if something is true, we want to execute something, or if something is false, we don't want to execute something, or it could be vice versa. They help us determine the relationships between two values. Are two things equal to each other? Or are they not equal to each other? Is one bigger than the other or smaller than the other? And they help us build into whether we want to execute an if, an elif, an else statement, or a match and a case statement, or if we wanted to go through a loop to how many times, or do we want to execute a loop at all if we're talking in the case of a while loop. We'll look at loops in a couple weeks here. And they will always return a true or false as a result. So there's only 6 main comparison operators in Python. And this pretty much goes for all languages too. So if some of you continue on to Java next semester, you'll be looking at these exact same comparison operators. All languages are essentially the same. It's the syntax that changes, using how do you finish a sentence, how do you do tabbing, how do you bracket your statements together and stuff like that. Those are the only things that change between language to language. So once you know one language, it's very easy to learn all the other languages. Okay, so the first one is equal to. This is different than the assignment operator. Remember, the assignment operator was, let me get a text box here. Okay, so the equal to is 2 equal signs, while the assignment operator is a single equal sign. All right, that single equal sign would be like my variable equals 10. And what it's doing is taking 10 and assigning it to my variable. That's why we call it a single equal sign, the assignment operator. If you have 2 signs, that is the equality comparison. Are they equal to one another? And then we have not equal. So if you've ever seen anything about programming or done a little bit of mathematics, the exclamation point means not. So in this case, we're literally saying not equal when we do exclamation equals. Greater than, we should all be familiar from that, from basic middle school or maybe even elementary school mathematics. We got lesser than. And then we have greater than or equal to, and then less than or equal to. And if you notice, the equal sign is always on the right side. So greater than, less than, not equal to. You might also remember, let's look at, we also had the plus equals, minus equals, divide equals, and multiply equals when we were doing the, what was it called? The arithmetic portion here. Let me just go add this here. We'll just go ahead and leave those. That way, if anybody loads this up, they'll see the additional information. So the equal sign is always on the right side, okay? And that goes the same too for when you're doing comparisons. So those are the 6 main comparisons, the only 6 comparisons that we actually have. So let's look at some different examples of when you'd use different ones. So the equality operator. Okay, equals to. We can assign, the value assignment operator into x. We'll assign 10 to y. And then we're going to check, are they equal? So the print is, does x equal y? That's going to return a true or false. And then does x equal 5? And that's also going to return a true or false. And there we go. So it does not equal y, but x does equal 5. So we know that is true. Looking at not equal sign. So same thing. A equals 3, B equals 7. Does A not equal B? Or does A not equal 3? Well, if A is 3 and B is 7, not equal, well, they're not equal. Literally, they're not equal. So that should return true. But A actually does equal 3. So this one would actually return false. So it's actually the opposite of the other way around. So you can almost think of equals and not equals, 2 opposites of one another, or reversing the true or false input or output. So in this case here, we get true that A does not equal B, and false A does not equal 3. If we wanted, we could even turn this into a formatted string. We'll go ahead and here and here. just so we can also exercise our formatting string. And here I could actually say A equals, B equals, and then it actually print out the values and then what it actually is. A equals 3 does not equal, actually no, because that turned in a straight string, and we want to evaluate. Equals, and then we can actually do the evaluation. A does not equal B, and that'll give us the true or false. There we go. So A equals 3 does not equal B equals 7. Well, that is true. It does not equal it. And then A does equal 3, so in this case, that would be false. Okay, greater than. Just like when you would do it in math before. This is very common sense stuff. If anybody doesn't understand it or is not sure, then at least these will provide a syntax example on how it looks. So greater than is age equals 20. Is, in this case, we're checking, is age greater than 18? Yes, age actually is greater than 18, so it's returning a true. And we need to understand these comparison operators if we want to be able to run our if statements, because we want to say, hey, if this is true, do this. If it's false, go to the else. So we got to be able to understand what comparison operators are used for. Same thing for temperature. Temperature equals 25. We'll do 2 checks. Is the temperature less than 30? True. We don't care what the value is. We just care that it's less than 30. And then temperature less than 20, that one is false. We don't care, that the temperature is 25. We just want to know, is it less than it? And then same thing for the equals and the less than equals or greater than equals. So, print temperature is less than or equal to 20, or print temperature is less than or equal to 20. I think I said less than before. So it's greater than or equal to 20 or less than or equal to 20. Actually, let's go with 25. Okay, so in this case here, we will also look print temperature is less than 25. Okay, so in this case here, the temperature is 25. It'll remember that from the previous block that we just ran. So it knows what temperature is. Let's go ahead and run it. And we should honestly, where did I mess up? Print temperature. Did I spell temperature wrong? Yes, I did. Variable naming is important. There we go. Okay, temperature. Run that again. Okay, true, true, false. So in this case here, we do actually care what the value is because we're also doing the comparison. Is it greater than or equal to 25? Is it less than or equal to 25? In this case, it is 25. So both of these are true because, yes, it is equal. However, when we look at is it less than 25, well, no, it actually is 25. It's not less than 25. And when you're dealing with integers or even floats, it only cares exact values. Okay, so we got true, true, false. So this builds into our conditional statements. If the video is laggy or anything, please let me know. I just got a pop-up saying there's a 4-second latency in here, so let me know if anybody has any issues with the sound or the video. Okay, next we're going to go on to our conditional statements, our if, else, if, which is abbreviated as elif, and else, and then we'll look at match case after that. Okay, so conditional statements are used for controlling the flow of your program. When you're going through the program, we could just go, all of our programs before have just been going from the top and then just go straight down to the bottom of the program. It never takes any left or right paths. It just runs every single line of code. Well, in your program, if you don't want, hey, thanks, Herf, sound and video, thank you. If we don't want our program to just go straight from top to bottom and run every single line of code, then what we can do is we can branch. If this is true, do this. So I'm making it look a little bit better. So looking at the if-else structure, so there's 3 different parts. The if portion is always required. So if you have an if and you just have the if, that's fine. You don't have to have an elif or an else, but you must always have the if. Okay. And then if there's an elif or an else, there must always be an if before it as well, because they're all one block together. It'll always go in that order. It'll go if, then an elif, and then an else if you have all of them together. Never out of order. Let's see. The elif and the else structure, as mentioned, they're optional. You don't have to have them. Okay. Let's look at a single statement. First one we'll look at of just having the if statements only, and then in order to execute one of those, we have to do a comparison. So if something is true, execute that statement. Okay? And then it'll only execute what is indented underneath of it. So we'll look at our first example here, because everything I just said is basically in text here. A lot of the text is here. So if somebody wants to review the video, or somebody who couldn't catch the live stream, they can look at the video later and see the code. Let's see. Let me zoom in so we can get a little bit bigger. All right, a little bit easier to read. Okay. So the first one we're going to look at is the full deal, the full Monty, I guess you can call it, an if example. My age equals 20. And we're going to check if my age equals 20, then we're going to run the first statement. If it does not equal 20, then it's going to look at the second statement and say, hey, is my age greater than 20? If that is true, it'll execute these statements. If that is also not true, then it's going to go to the else. The else is like the catch-all, to where if everything preceding it is false, it'll always execute the else. Because if everything else wasn't true, then that means the else must be true, because everything else was false. You don't have to have an else, but if you have an else, it is the catch-all for conditional statements. Okay, so if we run this, we should expect to see my age equals 20, so the first one should be the one that runs. So the if statement was true, so only this part runs, and it actually skips all the rest of it. So the if statement was true, all of this stuff is skipped. None of this code is actually processed. So this is how you can branch and only run certain parts of your code. Another example, okay? Same statements as before, but age now equals 21. So going through, well, my age equals 20. That is false because it is actually 21. So it does not equal that. Well, it's going to look at the next one. Age is greater than 20. That is true. So therefore, it only ran those middle two print statements. And you can see it ran both print statements because they are both indented underneath the elif. And in Python, there's two ways to do indentation. The first one is, so there's for proper formatting, you can go to the python.docs website, and they talk about the two ways. The traditional way was just to do 1, 2, 3, 4 spaces, and that was standard indentation. The new way is just press tab one time, and that is considered an indentation. So whatever method you use, whether it's 4 spaces or it's a tab, if you're working for a company, find out what is their standard. If you're working on your own, pick a standard and stick with it. Most people nowadays just use tab, and then all of their indentations are basically just a tab. Okay, so anything that's indented underneath this elif here was true, so only ran those two. It totally skipped the first if statement, and it bypassed the else statement because one of the statements was true. The first statement to be true is the only one that's going to occur, and that's important for later on. The first statement that is true is the only statement that will execute. Okay, and then the final example is age is 19. So it's going to look, oh, it ran all the earlier conditionals were false and skipped, so the else will only run as the catch-all because my age my age is 19, that does not equal 20, and it is not greater than 20, so that means it must be the else statement, and this will always run if you have it there if everything preceding it is false. Okay, if you want to run just an if statement, that's fine. Okay, so we'll go ahead and run that. So we're setting condition equals true because we're checking true or false for a condition. And if we wanted to run just an if statement, we can do that. See, look, we can run just an if statement. It'll run hello, and then after that if statement runs, it'll go back to running whatever it wants after that, the rest of the program. However, you can't do just an elif. So this is not okay. If I hit run, it's actually going to give an error, a syntax error saying an elif, where is the if statement that goes with that elif? So therefore, it's an invalid syntax. It actually thinks that we actually don't want the word el, is what it's looking. If I took off the word el, it would actually run just fine. So let's say you had a structure, you had an if block, you had an elif block, and you had an else block. Let's say you deleted part of it. Let's say you deleted the if part, and you got a syntax error. Well, that's one of the things to look at is, oh, look, I got a syntax error on my elif. Well, where is my if blocks? Okay. And then let's say you have just an else floating out there. Then that is also a syntax error. However, you can have an if. if condition, and we're going to say print hello, and then we only have an else. So in this case, we don't have a elif. You don't have to have an elif, and you don't have to have an else. They're optional, but how you mix them will have different things. So in this case, we're going to check if condition is true. So yes, condition actually does physically equal true because we said it. Print hello, and it's going to print hello. However, if condition is false, then it would then go down to the else because there is no elif statements to do any comparisons with. Another example, okay, so another single if statement. The username equals Tony, so this could be a hello, what is your name type input. Somebody types in their name, and then you can say if username equals Tony, well, welcome home, Mr. Stark, and then the program is going to continue. You see, it's going to execute this block there because the if statement finished running, it's tabbed over, and then if you look at this print statement is not tabbed underneath if. Therefore, it is not part of the if conditional statement. It is not part of this conditional statement, essentially. It is its own separate part. And it'll just continue running any code after the if statement's done. And it's all determined whether it's part of the indentation or not. If I were to indent it, let's see, in this case indent it, and they would have to go under something like that. It's only going to run the first piece. Delete the else. In this case, it still thinks it's part of the if statement. It's going to run both, right? But once we remove it, print, I'm still inside the if statement. Okay? Print both of those, right? Let's say we could say if the username does not equal Tony, then we'll skip this block altogether and it should only say program continues, right? And there we go. It was false because the name actually does equal Tony. Therefore, it will skip anything that's indented here in the text as an example of how the indentation works. All right, let's see. Continuing on down, if another example of a single if statement. So single if statements are really powerful for doing a one-time check. And if that check is true, change something. If it's not true, then just continue with the rest of the program. Okay, so another if statement, username equals Pepper. If the username equals Tony, welcome home, Mr. Stark, program continues. In this case, here we did the not if. Well, first we did the equals, and then we did the not if. In this case here, we're just checking, does it equal Tony? No, username equals Pepper. Therefore, we're not going to say welcome home, Mr. Stark, because Pepper's not Mr. Stark. And we're just going to go program continues and run through the rest of the program. Sometimes the program can use to be check a single if statements. Usually, however, it's more likely that you're going to compare two or more items within a branch. So in this case, you're going to have elif or else type statements. Okay, so let's say the student age, we're going to take an input. Let's say the student age is, what's the average age within the class? Let's say 19, even though I know there's some of you guys are a little bit older. I've been working a few years and just want to learn a little bit more. So how old are you? 19. So for some of you guys in the previous assignments, you missed the input. So pay attention here. Input. And then we're typecasting it to an integer, and then we're storing inside student age. Make sure you have your inputs on your functions, on your programs, okay? In this case, 19, you are not old enough to drink, okay? Let's try that again. I want to drink. So let's say I'm 22 now. You are old enough to drink. So that's a simple test example of checking somebody's age. If you're doing it like username, somebody types in their username and then they type in their password, and you could do welcome to the system, and then it starts loading up the system information, or it might say invalid user, and then it basically goes back to the login page and won't let the person inside the system. That's another way you can use it. So by using these if conditional statements, you can branch your system to execute different sets of code. Okay, if there's no questions on the if, elif, and else, we're going to go take a look at the match case. Match case was added in Python 3.10, and a big reason it was added was by popular user demand. Pretty much every other program language out there has a conditional system called switch case. I don't know why Python didn't want to stick with that name, because all the other languages use switch statements. Python just wanted to be special and added the match conditional statements instead, but they do the exact same thing. So with the if statements, we could be very generic. We could say, if age is greater than 20. Well, that could be 21, 22, 23, all the way to infinity. If you use match statements, then we're looking for exact matches. So we'll have a couple examples here, but we're looking for exact matches to a variable value, and then you can have a catch-all at the end. But we're not looking for, like, is age greater than 10, is age greater than, 20. You can do that, but that's not so much what the match case is designed for. The match case is designed for very specific inputs. So let's say you're doing a rock, paper, scissors game, and you want the user to enter an R or P or an S. Those are very discrete. Discrete means specific. Those are very discrete inputs, and those would be a perfect candidate for a match case conditional statements. Okay, it's looking for a series of patterns, and it's going to execute a block of code according to what pattern is matched to the variable. Okay, so what is a match case statement? It allows you to compare a single value to several different patterns and execute different code depending upon what the pattern matches. So the basic format here, it's going to have a little errors here because, well, I didn't declare pattern 1 and pattern 2. This is just an example. So we have our basic syntax. We have match. We're going to have a subject, and then we're going to match case. So the subject is like the variable. Okay, so this would be like the subject, and this is like our variable. And then pattern 1, pattern 2. This could be a pattern, or this could be our value. Okay, so it could be value of 1, value 2, and that's what the pattern is. And so this is just the basic structure of what it would look like. So you have your match, you have your variable, and then you have the semicolon. Okay, actually, let me delete these. That way I don't confuse anybody who's coming and watching these things later on. And then we're going to say, in the case that the subject matches this pattern or this value, execute this code. Pass just means go to the next section. It's a placeholder. So like if you're doing if statements or even a function or something like that, if condition equals true, pass, else, pass. And if you don't have pass in there, it'll actually give you an error. See, it doesn't know. It's like, hey, what's up with this else? There should be an indentation. There should be something here. Well, you can put pass, and look, it'll actually make the else error go away. Pass does nothing itself. It just tells the code do nothing, but it actually puts something there, so that way the program doesn't freeze up and give you an error when you try and run it. Okay, so that's all what pass is up here. A little bit of extra information there, but it actually literally does nothing. When the compiler sees it, just totally skips right over it. Okay, so this is pattern 1, pattern 2, and then if the variable doesn't match pattern 1 or pattern 2, then use the underscore here for the catch-all. So this is essentially like the else statement of an if-else conditional statement system. The case underscore is the catch-all. Okay, so if nothing else matched, for sure we want to do this. You don't always have to have it, but if you're doing a match case statement block, then it's good practice to go ahead and have the underscore in there. It could even be to say none of the above matched, or whatever comment you want to do. Or you could even have a blank print statement in there, but you should still have something in there. Otherwise, you could actually have your program crash for something that you might have totally overlooked, or when a new program comes in and looks at your code, they'll actually understand that this is the entire block here. So that's the basic syntax. Let's go ahead and look at some examples. So if we want to match an integer, let's say day equals 3. Well, 3, what is it, like 3 years old, 3 cats and dogs? What is 3? Well, in this case, we could say match the variable of day. If, in the case of a 1, print Monday. In the case of a 2, print Tuesday. You can see where this is going. In the case of a 3, print Wednesday. Let's go ahead and hit play, and we'll see which case. Oh, and then let's say they put in Sunday. Well, or 6, or 7, or 8. Because maybe on a planet there's 8 days in the week, planet not Earth, right? In this case here, we'll still catch it. And in this case, it's saying, hey, it's the weekend, so let's see what it comes out with. In this case, day equals 3, and the third day of the week, starting on Monday, is Wednesday. And it actually prints out the value of Wednesday. Let's say you're doing an RPG match, and you want to change it to a 1, 2, 3. Or let's say the computer did a 1, 2, 3 random value, and you want to change it into a RPG as well. So you can compare, does R equal R? P equal P, you could use a match case statement to very quickly and easily change the 1, 2, 3 over to an RP and S, not a G. RPG would be totally different. So an RP or an S for rock, paper, scissors, right? So just giving some examples here of how you can apply this on an upcoming assignment that I believe is due next week for your conditionals program. Okay, we can also do multiple cases. So we can match multiple cases. In this case here, we have day equals 6. We're still matching the variable day. And we're going to say the case of 1. If you have a single pipe here, that is similar. That is like the OR. It's basically an OR. You have that, and you also have the AND. Okay, in this case here, only the OR works for the match cases. Because you can't have a variable equaling more than one thing. This only looks at one variable. That's one thing. The if blocks can actually look at multiple variables. The match, you want to look at one variable and compare it to a pattern. So in this case, the pattern is a 1 or a 2 or a 3 or a 4 or a 5. And we're going to print out its weekday. We can say a case of 6 or 7, it's the weekend. And then we have our catch-all, our underscore here, for an invalid day number. Let's say somebody puts in an 8. Because they're on Mercury or whatever. Okay, we hit here, day 6. Hey, that's the weekend. We're not saying what day of the week it is. That was the previous function. In this case here, we're saying if it's a 6 or a 7, it's the weekend. You can also, now, before I said you can't really do, like, is X less than? You can, but you're still trying to match a pattern. Okay, so this is called guard clauses. And it uses the keyword if. That's why you can't use if as a variable, because one, you have your if conditional statements that we just learned about, but in this case here, if is a different keyword. It's basically taking the if statement and not using an elif or an else. It's just using the if portion of it to give us a true or a false. So we're saying age equals 20. So looking at the variable age, in the case that x, we're looking, is it true or false? Is x, if x is less than 18, then that x here must be true. You are a minor, all right? If x is less than or equal to 18 or great, so is it between, this is a span block here. So basically you're saying if x is greater than or equal to 18 or less than or equal to, well, we'll just stick with less than. I guess there was just a less than there, 65, then you're an adult. In this case, if x is greater than or equal to 65, then we're going to execute this case statement here. So you only have one value that you're looking at here, in this case, x. So in this case, case of 20, because it's looking at the value here, right? Case of 20, but then we're going to add in a guard to specify what value of 20 we want here. All right, so in this case, let's go ahead and hit run, and we'll see what we got here. Okay, age of 20, you are an adult, because x is between or greater than 18 and less than 65, or between these two values right here, right? If it is 15, then it's going to match another statement. Okay, you are a minor, and then if we are 65 or above, so it's going to take in the value of x. It's going to be 65, 65, 65, but it's only going to execute this case of 65 if x is greater than or equal to 65. There you go. You're a senior citizen. All of us will get there someday. Luckily, I'm not even there yet. Okay, so this is the last match case statement. So we looked at a couple different ones. We looked like what if it's an integer, looking at a single match case. We looked at multiple match cases. And then we looked at what if we're just looking at a single value, but we want to execute different case statements depending upon what the value is. Then we can add guard clauses to make it more specific for each one. So if you need to refer to this document here is shared on this YouTube video in the comments. And also I'll post it in the Discord, so that way anybody can always at any time come and look at the if, else, and elif statements, the conditional statements, the logical statements, the comparison operators, everything we've just reviewed. They can look at it any time. We got one last piece here. Yeah, we're definitely going to keep this video shorter this week. Okay, logical operators. Last bit here, 9 cells to look at. This will be super easy. Okay, so we looked at the comparisons. That's the equal than, not equal to, greater and lesser than. Then we looked at conditionals, the if, elif, and else. Then we looked at match case as an advanced form of the conditional. Finally, we're going to look at logical operators. Logical operators are the and, or not. Not the exclamation not, but the not logical operator. Which basically makes something the inverse or the opposite of what it's actually supposed to be. So it allows us to combine multiple statements together, especially if you're looking at the if statements, and be more dynamic and flexible within our code. And it still, in the end, will only return a true or false condition. But it lets us assess multiple true or multiple false or some true, some false values and come up with a final single true or false. All right, so if we have an and, then both items must be true, okay? It could be like our planet equals Earth and person equals human. Well, both of those have to be true, and it'll return a true at the end because it has to be one, or the A and B have to both be true. If one was planet Earth and then the person was Martian, well, Martian is false, therefore they're both not true, therefore it's not A and B. However, if or just means that you can have a bunch of different statements of true or false, only one of them has to be true with an or block. And then not basically turns the opposite. So if you said Earth and human, you could say not Earth and not human. That would return false and false, and therefore that would actually return a true value in the end. Logical operators can get kind of confusing, so if you use the not operator, use it knowing what you're getting to, and maybe even include a comment in your code. That way if another programmer comes and looks at it and says, why is he using not here? Why he just use an opposite variable, then he'll actually understand what the logic was on that. They're great for using with the if, while loops, and things like that. So the if statements and the while loops, they're just a great way to make the flow more advanced. So let's look at the and operator first. So that it checks if both conditions or all of the conditions must be true. So let's say we have age equals 20 and is student equals true. All right. If the student is true, they'll get a discount, but they have to be over the age of 18. So if age is greater than 18 and is student equals true, the engine is going to compile or evaluate these to age is 20, so that is true. Is student is true. Both are true, so A and B are true. Therefore, it's going to execute this first statement here. Otherwise, it would print this one here. Well, let's check. You are eligible for the student discounts. Yay, okay, we're all eligible for the student discounts. And then remember, both conditions must be true, then the result will be true. If you're taking two different true statements, and with the and, you're combining them into a final true or false value. Hopefully it's clear as mud, right? Okay, let's look at the or operator. The or operator says A or B has to be true. Not both of them, just one or the other, right? So the or operator says at least one of the conditions is true. If either condition is true, the overall result is true. However, if both are false, that means it's false. Because A is false, B is false. Well, they're both false. There's no or about it. Another way to phrase it, returns true if at least one condition is true. All right? So age equals 15. And in this case, membership is false. So if age is greater than or equal to 18 or is a member, so in this case, this should be false, right? Because they're only 15 and they're not a member. They're both false. This should evaluate overall to false. Let's check. All right, yep. In this case, it defaulted to the catch-all. You cannot enter this event, right? Okay, finally, we're going to look at the not operator, and then we'll combine it all together. and look at 2 good examples here that'll help you on your final assignment for this week and next week. Okay, the logical operator not. So basically it inverts whatever decision we make here. So is raining equals false, right? So if not is raining, execute this first one right here, right? So the way to think about it, let's look without the word not there. Let me cut that. So if is raining, you can go outside. Is raining is false, so that means this would be false, right? Well, in this case here, if we add the word not, it now becomes true. It basically becomes the opposite of what it had. So without it, we have false. With it, it becomes true. Basically just negates it or turns it into the opposite value. So if we run, let's see, raining is false. Therefore, if it's not raining, you can go outside. The other way to think about that, though, is, well, sometimes the not could be confusing. So this was just an example, but if you want to make it more readable, then what you would do is if is raining, and you would actually just switch the statements. Put that one down there. There we go. So if raining, if that is true, then bring an umbrella. If it's false, don't bring an umbrella here, right? You can go outside and play with the umbrella. So if you switch by not having the not there, it basically just swaps what we're checking here with the else statement, right? So the not can be a little confusing. If you want to keep it simple for other programmers, think about not using the word not. That's a double negative, but we'll go with it, right? Okay. But if you can't do that, then have a good reason for it, because all you're doing is you're taking if is raining, that's a false statement, you're just converting it to true. All right, let's combine them together. Okay, we only got one big example here, and then we're going to bring it all together. All right, so age equals 16, has parent permission. This person wants to go to a concert. Unfortunately, if they are under the age of 18, they have to have parent permission. So what we can do is we can say, we can have a comparison with an or statement. And then in parentheses, we want to execute this one first. We're going to have an age and has parent permission. So we only need or, so we only need the left side to be true, or we need the right side to evaluate to true because we're using the or, right? So is age greater than 18? False. Okay. Okay, so this one here would be false. All right. Well, let's look at this part here. In this case, we're looking at or. So we only need one of them to be true. Age is greater than or equal to 16. Well, that is true, but we have an and here, so both of these have to be true. Okay, so the first half is true. And do they have parent permission? Well, has parent permission equals true. Therefore, the overall section on the right side equal to true. We have an or statement, so either the left has to be true or the right has to be true. Well, the right happens to be true, so it's going to execute the first statement. You can attend the concert. We will run to verify it because we always got to check our logic for logic errors, right? Because if, in this case, we know the if statement should run, logically we ran through it, so we are expecting you can attend the concert. If we get you cannot attend the concert, that means there's a mistake in the logic somewhere. All right? So yes, you can attend the concert. So our logic was sound, our programming was good, it executed what we expected to execute. And it's always something to think about. I believe in week 4, maybe in week 5, I'm starting to toss in logic errors. Definitely, yeah, module 4, there's going to be some logic errors because you guys are getting pretty good at syntax errors, identifying, missing semicolons and things like that. But logic errors are something else altogether because you have to kind of know what the answer should be expected to be. And if it's not that, that means there's something wrong with the logic, but the code is correct. But it could be something as like an equal sign is missing or a greater than sign is missing. Well, technically, if the equal sign is missing, then age greater than 18 is a valid statement. That is good syntax. But the logic is false. So in this case here, we got the right answer, so that means our logic was good for this particular example. All right, let's bring it all together. Slicing strings we're not going to do today, so we have 7 more blocks. These are just 2 examples that we're going to run through here. If you're at home, okay, okay. Thought I was missing my code there. Okay, so let's say you want to check leap year. This is very similar to an assignment you have this week where you're using the modulo value to check if modulo of something equals 0, okay? So how do we check if something is a leap year? Well, there's 3 conditions that are required in order to meet a leap year. Well, we're going to get an input from the user. Let's see. Let me see if I can get this to show. Google, how to determine if a year is a leap year. Google that, and I will share this screen. Nope, not that one. That's my OBS. Let's see. Let me add in, just so we can see something a little bit nice, window capture. This will be Google. Okay, and in this case, there we go. That, and do that. And drag this down the main menu here. Sorry, setting my OBS real quick. All right, there we go. And it's going to take up the whole window. Wow, that was big. Okay. Crunch it down just a little bit. Okay, there we go. Let me see. Hopefully that looks okay for everybody. I'll zoom in a little bit here. Okay, so in order to know if something's a leap year, we have to have 3 things. So can it be divided by 4? If it's divisible by 4, it's a leap year. Except if the century is divisible by 400, or the century must be divisible by 400. Like 1900 is not divisible by 400, so therefore, no, it would not be. And I believe there's also another. If the century year ends in 00, it must also be divisible by 400. Must be divided by 4. Yeah. So, okay, it has to be divisible by 400 and divisible by 4. Both of those must be met. So let's go ahead and take a look at the code here. There we go. In this case here, we're also checking if it's not a leap year. So if the leap year is divisible by 400, so in this case we're doing modulo 400, if it can be divided by 400, we should have no remainder, right? Remainder should be equal to 0. If that is true, it is a leap year divisible by 400. Because that is also divisible by 4, right? So it meets the 4 and 400 criteria. If it's divisible by 100, it is not a leap year. And we're checking this after 400 because all the 400s are going to get caught first. That only leaves the 100s, 200s, and 300s next. Because remember, the first true statement is the one that's going to be executed. So if it's divisible by 400, it's not even going to look at the rest of these, right? That means if it is not divisible by 400, then it has a chance to look at this, which only leaves 100, 200, 300. And the next, we're going to look at, well, okay, none of those are true. Well, let's see, is it divisible by 4? In this case, 400, but not by 100, right? So that would give us a leap year. And then Elif, not a leap year at all. It's not divisible by 4 at all. I thought it had to be divided by 4 and a 400. In this case, that both those would be true if it could be divided by 4, okay? So let's go and run this. Let's enter a year. If anybody in chat wants to give me a year, I'm not sure how bad the latency is, but if somebody wants to give me a year, we'll type it in. If I don't hear anything, then I will just go ahead and type in another year. Bueller? Nobody? Doesn't have to be interactive. That's fine. All right, I'll go ahead and type in one for a test here. Let's go with 2000. Was the year 2000 a leap year? 2000 was a leap year because the first one got called on divisible by 400. All right, so the first one was called. I got Herv, thanks, 1973. 1973. Oh, nope, run. 1973, we've got to press enter, not the run button again, okay? 1973 is not a leap year because it's not divisible by 4. Let's check 1940, right? 1940. Was 1940 a leap year? 1940 is leap year because it's divisible by 400, but not by 100. Well, interesting. What if we did 1900? Let's try that. 1900 is not a leap year because it's not divisible by 100, or it is divisible by 100, but not by 400. So actually 1900 is not a leap year. Oh yeah, good one. 1984. 1984. I was just a little kid. All right. It was a leap year. All right. So by using module, this is very similar to another assignment that everybody has due this week. Some of you have done it, but most of you have not. So what we're doing is we're taking a value, we're dividing it by 400, and we're checking what is the remainder. If the remainder is 0, then that means this is true, right? Because left side equal to the right side. If the remainder is 0 when you divide by 400, execute this if statement and ignore all the rest of it. If all of these are false, well, then the last statement must be the true statement, or will be executed. Doesn't mean it's true, it just means that that is the block that will be executed. All right, so that's our first example. It is applicable to the assignments that are due this week, so I hope I can tell when people don't watch the live streams or even the recording of the live stream, because I guarantee somebody's going to miss this problem right here in the homework when the answer is right here staring in the face in this live stream. All right, I'm not giving them the answer because it wasn't this exact question, but this helps them find the right answer. All right, and then let's determine a letter grade. So A, B, C, D from a percent score. All right, so this is another case. In this case, the first one we were looking at numbers. This case we're going to go from a number into a letter. So in this case here, score, we're going to input in a score between 0 and 100. If the score is outside of those ranges, we're going to say basically, hey, that's an invalid score. If it's less than 100, or see, look, we got our logical operator in with our comparison operators in a single if statement. Then we actually jump into an else, and then within the else statement, because remember, if the first part's not true, it'll always execute the else. Then we're going to have a nested if statement. So nested means there's an if statement within. One thing I want to point out is the tabbing. So if this print statement falls within this if, this whole block here falls inside of this else statement right here. That's the first. That's the outer if else statement. And then we have an internal one, which has its own indentation. So there you see this print statement here is indented to this if statement. Therefore, this print statement belongs to this one. This print statement belongs to this one. All right. So if I know somebody was messaging me 2 days ago, really confused doing the practice problems on indentation. Here is a perfect example of how indentation shows ownership. So this statement owns this block. This elif owns this block. This elif owns this block, and so on. But this else owns this entire block right here. Hopefully that makes sense to everybody. If not, contact me on Discord and we'll go over some more examples. All right, so we're going to get a score between 0 and 100. If that is true, then it's going to execute this else block here. And then we're going to say, if the score is greater than or equal to 90 or less than or equal to 100, execute that block there. There is a way to make this more simple. Herv, if you want to try and take this on a challenge on how to make it more simple, I dare you to give it a try. Or anybody else, if you want to give it a challenge, you can text me or message me in Discord and show me how can you actually execute this block here without using any of these ranges. See if you guys can figure that one out and message me in Discord for those that want to do it. All right. Well, let's go ahead and see what it is. Okay, let's input a score, and just to show that it does work. Let's go with Herv, if you want to throw out a number out there, or anybody else that's viewing. I see we've got a couple concurrent watchers right now. A couple people are watching, so if anybody wants to throw out other than Herv, he's the talkative one tonight. Let's go with let's say, hey, they got a 23% because they did not follow the rubric, right? Everybody should be looking at the rubric. Press enter. Yep, they definitely got an F if that's all they did because they didn't follow the rubric. Speaking of, if you don't turn in your Python file, that's 1 point in the rubric. If your program doesn't run, that is half of your grade on all of these assignments. Your program has to be able to run. It's funny how many people like to turn in programs that don't even run. All right? Throwing that out there. So always test your code before you submit it. If it doesn't run, let me know and I'll help you fix it so it does run. But it's silly to lose half of the grade to get an F essentially because you didn't test to see if your program even runs. All right, let's test 42. Thank you, Herv. 42. It comes out true because, well, it looked at the first ones. 42 is not between 90 and 100. Or the score is 42 is not greater than or equal to 90, and the score is not less than or equal to 100. Both have to be true in order to get the A. In this case here, we are defaulting down to the else block because everything else evaluates to false, essentially. Okay, let's try one up in the mid-range. Let's say somebody did a 100. We're going for the max range here. And that comes out to an A. Let's go for the min-range, right? When you're testing your code, you should always test the maximum and the minimum values, right? That comes out to an F. And then what we'll do is now we're going to test a value outside of our ranges. Let's test 101. Invalid score. So we know an invalid score. Let's test a negative number. -1. Invalid score. So we know it has to, first check is good. We know the else block is good. Now we need to check the values in the block. Okay, so we checked 100. That was good. Let's check 85. B, okay. Let's check an edge case. So an edge case means like, if we're looking at C, 70 or 80 are your edge cases. And what that'll do is that'll show you if you're missing like the equal sign. That'll show you you're missing an edge case, right? In this case, a C, we're saying score is less than or equal or less than 80. So if we put in 80, it should actually come out as a B, right? And that came out as a B. So we know we don't accidentally have an equal sign in there. And we'll look at one more. We'll try and do the edge case for a D. Let's try 60. All right. So that is one good way to thoroughly QA your code, is test every single range and all the edge cases for all the different options to see, was there an equal sign missing? Is there a greater than sign or a less than sign? Is there an and or an or missing? Or is something not being caught within the range? We'll look at some common mistakes. First one is not indenting your tabs underneath your conditional statements. Using a single equal, if the input is a string, would that crash it? Yes. Or no, it should not crash it because that would be an invalid score, right? Well, let's try it. I think you might be right because it'll say, I bet we'll get a value error. Let's try it. Hello. Value error. Yep, I was spot on. We got a value error, right? So yeah, good question. I think you knew the answer to that one. I think you were just checking to see if I knew the answer to that one. I see what you were doing there, Herv. Okay, so a value error, right? Because you can't check, is a string less than 0 or is a string greater than 100? Because how do you say hello is greater than 100? You can't. So there you get that value error. I know Herv knew the answer to that one. He just wanted to check if I knew the answer. Okay, there we go. That way it looks pretty. Okay, look at the common mistakes. So not indenting properly. All right, so we have this good example right here of indenting ownership, right? How to do your indenting. Using an equal sign instead of or using an assignment operator instead of using a comparison operator for equal to. And then logic errors, right? Saying, checking if something is only greater than, but then, so let's say age as greater than 13. Well, let's say we forgot the equal sign here. Let's go ahead and run this. Age equals 21. Okay, you are a teenager. Let's say age equals 13. 13 should be a teenager, right? But, oh, you are a child. So therefore, we know we have a logic error. We are expecting teenager, but teenager didn't run. So then it ran the code just fine. So there's no syntax errors. There's a logic error in here. So if we look, if age is greater than 13, oh, duh. That should be either age is greater than 12 or age is greater than or equal to 13. There's two different ways you can do it. There's no one single right way to code every single thing. But you want to be consistent. Here we're doing greater than or equal, and we're doing to each value, so we do the same thing here as well. In this case, 20 or older is an adult. Not old enough to drink, but still an adult, right? You can still serve your country, but you can't drink yet. A lot of people have issues with that one. Strange fact, if you're in the military and you live in Japan, you can drink at the age of 20. Americans can drink at the age of 20 in the military in Japan. So for all of you that want to drink 1 year earlier, go sign up for the military right now and go get stationed in Japan, all right? Just kidding. Don't make that the reason to drink, okay? So we found that logic error that we made right here, right? So now we're going to try it again. 13 comes out teenager. So we've just fixed that. Oh, I did not know that about France. Okay, that's another good fact. Now the question is, do they let the military drink in France at the age 20? Because when I first went to Japan as a young Marine, like back in the late 90s, 20-year-olds couldn't drink. But it wasn't until they said that wasn't fair because all the Japanese people could drink, but the Americans can't, that they started, after I left Japan, they actually started letting people drink there. So do you know that applies to military? All right, there you go. Learn a new fact. All right, so we checked a logic error. Let's try a different age. Let's say somebody is 21. What does it come up with? Teenager. Huh. So Herb, what's going on this one, huh? Oh, you're French. Oh, okay. Well, that makes sense. Okay, so if the age equals 21, well, the age is greater than or equal to 20. Why is it still saying they're a teenager? What is the issue here? And this is actually something that you'll see on the homework assignment for this week here that deals with the modulo. So it's part of this one here, this logic error that we're talking about here, because the code runs, right? The code runs just fine, but if you put the age 21, we're expecting it to print you are an adult, but it did not. Does anybody know what the issue is? Herb, you can speak up if you don't. If not, then I'll go ahead and point it out of what the issue is. But this is another example of a logic error because we did not get the result that we were expecting. Because both first two tests give the same value. That is correct. So the age is greater than or equal to 13. That is a true statement. Only the first block is going to run. So anything 13 years or older is going to run. Good job catching that, Herb. Okay, and you can see I did that on purpose, right? Example of a logic error. Okay. So what you can do is then what you could say is you want to look at your worst case first. Oh, actually, I think I have it fixed right here. Okay. So here we have the corrected logic error, the next block down, right? We're going to run this one, age 21. There you go. You are an adult. You want to look at your max case and work your way down, or look at your minimum case and work your way up, right? So if you work at your minimum case and you say if age is less than 13, you're a child, then you'd look at the middle range for teenagers. Then you would look at the maximum range for an adult. Or you can look at the max range like we have here, look at the adults first, then you look at the middle range, and then whatever's remaining will be the bottom range. So don't mix your numbers up. Don't, like if you're doing an ABCs thing, don't look at grades for a C first, then a B, then an A, then a D, then an F, because the numbers need to go in order of your checks. Start with the maximum values and work your way down, or start with the minimum values, work your way up. Don't mix them up or you will get a logic error. So remember that when you're doing your fizz buzz exercise this week. If the numbers aren't fizzing, buzzing, or fizz buzzing like you're expecting them, you might have a logic error in the order that you are checking. All right? So that's my 2 hints for this week. The modulo exercise, hint, hint, look at it. I think, Herb, you're already done with these assignments, but most of the class is not done. So here's your first hint. Here's the modulo, equal to 0, hint, hint. And then here's the other one, logic error. Make sure your logic is in the right sequence. Maybe you're checking the right values first before you go and check other values. Second hint, hint, and that'll help you with the fizz buzz. And another nice note about the fizz buzz is actually a very common a programming interview question. It might be so common now that companies are moving away from it, but up to like 5 years ago, even 3 years ago, companies actually had people program the fizz buzz logic program, like logic script, as part of their interview processes when they had to demonstrate their ability to code, because one, it's short, and two, it demonstrates your ability to catch logic errors like this. All right. That was my last example. We're not going to do slicing strings because, well, I have it all built out here. But really, you want to loop through that. Actually, move part of it over to another brief or lecture already. But slicing, you want to be able to loop through your strings when you slice them. So hopefully that answered everybody's questions. that's going to help everybody out for this week. That first bit there was actually for Herv because he was asking about strings last week on how to replace pieces of strings. Remember, we got the strip to remove all the white space on the outsides or the beginning and the end. We have replace for removing any part of the string, and then we have the regular expressions, which we're actually going to look more at the regular expressions next week because that is the industry standard or the professional use of replacing characters inside strings is the regular expression. But, we have 3 examples here. Those examples, that was for you, Herv. And that's all I got for tonight. If anybody has any questions, feel free to ask. I'll hang out for about 5 more minutes. I only want, an hour and 12 minutes. I only wanted it to be an hour or less than an hour, but we made it to an hour and 12 minutes. Okay. Someday I'll get these down to 30-minute snippets, and we'll make them more efficient. But, I'll hang around for about 5 more minutes. Let me go ahead and throw there. Do I got a fancy one up for that one? Video capture, just chatting. Oh, I guess I didn't set that one up yet. Okay, I'll just leave it on the scene. Yep. Math logic. So logic operators, now you mention it, there is actually an order of precedence to logical operators as well. So your and, your or, and your not actually have a precedence. It goes and is first, has priority over the others, or has second priority, and your not has a third priority. Yeah, it is actually in, let me just double check, but I believe it is in the comments. Yeah, there you go. So if you look at the comments for this video, even the live stream itself, scroll down, look in the description. I think that's what that section is, where you show more, show less. The link to this Google Colab's already in there. I make sure I include it. But also I'll post it in Discord just in case somebody doesn't actually look at the video and they just want to see the Google Colab. So, yeah. Anything else? Let's see. Introducing the match case option. Very useful. Yeah. So the original course doesn't talk about match case because it's a newer thing. I think 3.10 only came out like 3 years ago maybe. So it hasn't been around that long, but people basically had the switch case in every other programming language, and so Python, they went ahead and gave in the creators of it, and they added the match so that we have something as well. I wish they would have called it switch instead of going with match because that would just make more sense to keep language terminology common, because every language has a for statement, every language has a while statement. Python does not have a do while statement though. I don't know if you look at Java, C++, C, there's a loop. So when we get into the loops, we'll talk about the for loop and the while loop. We don't have a do while loop in Python. There's ways to get around that, but it's something that we don't have. But every other language does have. So we'll see. Maybe Python will add a do while loop in the future. We'll see on that one here. Yeah, some things I've been working on with my Python is trying to do Q-learning models to teach AI with reinforcement learning. So that's a lot of fun as part of my PhD classes. So, all right. Well, it doesn't look like there's any other questions. Thanks for everybody. And for those who catch this video later, if you have any questions about something you've seen here, just contact me on Discord, send me an email, and I will answer them. All right. Thanks, everybody. Everybody have a good day.